This is Hymavathi, working as an assistant professor in the Department of Humanities and Science, MLR Institute of Technology, Hyderabad. So, in the last session, we discussed about non-exact differential equation and finding an integrating factor and how to find the general solution of an integrating factor using method 1. And also we did one problem on method 1, finding an integrating factor, and also we discussed method 2 of finding an integrating factor. And today in this session we will discuss about the method 3 of finding an integrating factor, and we will do the problem on finding an integrating factor, and we will also find the general solution of non-exact differential equation. So now let me see. So what is the method 3 of finding an integrating factor? So why we are using an integrating factor? We have to find a general solution of non-exact differential equation. So see the method of finding an integrating factor. Suppose the given differential equation is non-exact and also of the form y into f of xy dx plus x into g of xy dy is equal to 0. Suppose the given differential equation is non-exact and also of the form y into f of xy dx plus x into g of xy dy is equal to 0. So, if the equation is this is of the form, then to find the integrating factor is 1 by mx minus ny is an integrating factor. Right, now let me see one problem on finding an method 3 of integrating factor. So, then how can we find the general solution of this differential equation is? So, first you have to verify the given differential equation is non-exact. So, this is the condition of non-exact differential equation. Then later find the integrating factor. After finding the integrating factor, you have to multiply this integrating factor to the given differential equation. Then automatically the given differential equation is reducible to exact differential equation. Then finally we will find the general solution. Then how can we find the general solution of exact differential equation is, we know that, then how can we find the general solution of exact differential equation is integral m dx plus integral n dy is equal to c. Integrating on m, so treat y as a constant. And integration on n, you have to take the terms free from x and do the integration with respect to y. This is the process we are following to find the general solution of a non-exact differential equation. So, now we will see the solution. So, first see the solution of this differential equation. So, now the solution is, so first you have to multiply y with the first term y into x square, so y square plus 2y dx. So, first I am writing the given differential equation x into 2 minus x square y square dy is equal to 0. And now we have to multiply with this x square y cube plus 2y square dx plus, and multiply with this x 2x minus x cube y square into dy is equal to 0. So, now the given differential equation is of the form m dx plus n dy is equal to 0. And now separate the m and n functions. So, here m is equal to x square y cube plus 2y square is the function m. And now the function n is 2x minus x cube into y square. And now we have to verify the non-exactness condition. So, what is the non-exactness condition? Dou m by dou y is not equal to dou n by dou x. So, now we have to find the derivative on m with respect to y, treating x as a constant. So, with respect to y differentiation on m here, x square is a constant. The derivative of y cube is 3y square plus, so now the derivative of y square is 2y. So, after the simplification, we will get 3x square y square plus 4y is dou m by dou y value. And now we will find out what is dou n by dou x. Now do the differentiation with respect to x, treating y as a constant on n. The derivative of x is 1 minus the derivative of x cube is 3x square and y square is a constant, right as the same. So now the dou n by dou x value is 2 minus 3x square y square. Now observe that these two partial derivative values. So these two are not equal. So dou m by dou y is not equal to dou n by dou x. So that this differential equation is a non-exact differential equation. And now we will find out what is an integrating factor. First observe the given differential equation. So now the given differential equation, so this is of the form y into f of x comma y dx plus x into g of x comma y dy is equal to 0. So clearly this differential equation is of the form. And now what is the integrating factor to find? The integrating factor is 1 by mx minus ny is an integrating factor. Now we will see to find what is 1 by mx minus ny of the given differential equation. So right, this is the given differential equation. Then after multiplying with y and x square y cube plus 2y into dx plus 2x minus x cube y square into dy is equal to 0. Now we are finding an integrating factor. So integrating factor is 1 by mx minus ny is an integrating factor. So now, so do the integrating factor here. So here this is the function m and this is the function n. So for the function m you have to multiply with x and for the function n you have to multiply with the y. So m is nothing but x square y cube plus 2y into x minus, so here the n is 2x minus x cube y square into y. And now we will do the simplification of this. So first multiply with the x. So x cube y cube plus 2xy minus, for the second term multiply with the y, 2xy minus we will get the plus x cube y cube. So now here minus 2xy and plus 2xy gets cancelled. So here we have the 2 times of x cube y cube. So now the integrating factor is 1 by 2 x cube y cube is an integrating factor. And now we have to multiply this integrating factor to the given differential equation. So this is the given differential equation. So for this given differential equation, we have to multiply with the integrating factor. After multiplying this integrating factor, so now the given differential equation is reduces to the exact differential equation. So now see the multiplication, x square y cube plus 2y divided by 2x cube y cube into dx plus 2x minus x cube y square by 2x cube y square into dy is equal to 0. And now split the terms here. So here the first term is after the cancellations. So we will get here 1 by 2x plus, now the second term is 1 by x cube y square into dx plus, So in the second term also split the terms. So after the cancellations, so we'll get here 1 by x square y cube minus 1 by 2y into dy is equal to 0. So now again this differential equation is of the form m1 dx plus n1 dy is equal to 0. So clearly here m1 is equal to 1 by 2x plus 1 by x cube y square. This is the m1. And coming to the n1, n1 is equal to 1 by x square y cube minus 1 by 2y. And now we will verify whether this differential equation is exact or not. So what is the condition for the exactness? Dou m by dou y is equal to dou n by dou x. So for this equation, to verify the exactness, the condition is dou m1 by dou y is equal to dou n1 by dou x. So now we will see the derivative with respect to y on m1. So here this term is a constant when we are doing differentiation with respect to y, so that this derivative is 0. Coming to the second term, 1 by x cube is a constant, and now the derivative of 1 by y square. The derivative of 1 by y square is minus 2 by y cube is the derivative of 1 by y square. So this derivative value is minus 2 by x cube, y cube is the value of dou m1 by dou y. And now we will find out the dou n by dou x. So now see the dou n1 by dou x with respect to x differentiation partially keeping y as a constant. So here 1 by y cube is a constant. Now the derivative of 1 by x square is minus 2 by x cube minus, so here 1 by 2y is a constant since we are doing differentiating partially with respect to x, so that this derivative value is 0. Derivative value is 0. So now this value is minus 2 by x cube into y cube. Now verify the two partial derivative values here, that is dou m1 by dou y and dou n1 by dou x. So here the dou m1 by dou y value is minus 2 by x cube y cube and dou n1 by dou x value is minus 2 by x cube y cube. Now these two values are equal. So dou m1 by dou y is equal to dou n1 by dou x. So now this differential equation is exact differential equation. So now we will solve the general solution of exact differential equation. Then how can we find the general solution of the exact differential equation? Now we will see the general solution of this differential equation, right? So this is the exact differential equation now. Now we will find out the general solution of this m1 dx plus n1 dy is equal to 0. So to find the general solution of this, so integral m1 dx plus integral n1 dy is equal to c. So integrating on m1, keep y as a constant. Integrating on n1, take the terms which does not contain x. That means you have to take the terms free from x on n1. And now take the m1 function. Here this is the m1, 1 by 2x plus 1 by x cube y square into dx. So here y as a constant plus, and now we have to take the n1. So what is the n1 function? Here n1 is 1 by x square y cube minus 1 by 2y. Then what is the condition we have on n1? So which does not contain x terms only you have to take. So in this n1, only the term is minus 1 by 2y which does not contain x. So that here n1 is minus 1 by 2y dy is equal to c. And now we have to integrate. Integration 1 by 2x dx plus, so in this second term 1 by y square is a constant right before the integration, 1 by y square integral 1 by x cube dx minus integral 1 by 2y dy is equal to c. So now see the integration here, 1 by 2 is a constant, then now the integration of 1 by x is log x plus 1 by y square into the integration of 1 by x cube is x to the power minus 2 by minus 2 is the integration of 1 by x cube minus 1 by 2 into integral 1 by y, that is nothing but log y is equal to c. And now see the simplification here. So 1 by 2 log x plus, so here we will get the minus, so plus into minus is minus, minus 1 by 2 x square y square minus 1 by 2 into log y is equal to c. So in all the three terms we have 1 by 2, that 1 by 2 take the common and bring that 1 by to the right hand side. So that we will get here log x minus 1 by x square y square minus log y is equal to 2c. And now again use the formula of log a minus log b. Log a minus log b is log a by b. So log of x by y minus 1 by x square y square is equal to 2c. This is the required solution of the given non-exact differential equation. So this is the general solution of the given differential equation. So that is the solution of the given differential equation is of the form x into function of xy dy plus y into function of xy dx is equal to 0. So in this session we discussed the method 3 of finding an integrating factor. So what is the method 3 we discussed? Y into f of xy dx plus x into g of x comma y dy is equal to 0. This is the form. If this is of the form, integrating factor is 1 by mx minus ny is an integrating factor. And after getting this integrating factor, you have to multiply with the given non-exact differential equation. Then the non-exact differential equation is reduces to the exact differential equation, and then finally you have to find the general solution. So this is the topic we discussed in today's session. In the next session, we will discuss about the method 4 of finding an integrating factor. So in this next session, we will discuss the method 4 of finding an integrating factor.